Hello dear friends, I want us to look at the question we can see I have here on screen, which is simply going to be the integral going from 0 to 1 of e raised to the power negative sine inverse of x dx, or e raised to the power negative arc sine x dx. So friends, let's just start with it. And friends, please make sure you watch the video from start to finish so that you can have a clear understanding on the methods in which we are going to be using while solving the problem today. So friends, let's have the question displayed. Here is it, friends. So friends, which integration technique do you think can work for this integral? Because guys, keep in mind that the moment you don't know the best technique to use, your chances of passing the particular question becomes very slim. So friends, which integration technique you think can work for this integral? Because friends, as you can see, partial fraction is nothing. Partial fraction can do for us. Integration by parts, I don't think so, because integrating this our whole function is crazy. Likewise, differentiating it as well is very crazy. Good. So we cannot use even trigonometric substitution, no. Integration by parts, no. So friends, you guessed it right, we are going to be using the u substitution. So friends, in this case, we are going to let our u to be sine inverse of x, or arc sine x. Okay, we are going to let u to be sine inverse of x. If we take the original sine on both sides, friends, we are going to have our sine u to be the same like x. Okay, if we take the original sine on both sides, that's a normal sine on both sides, we are going to have sine u to be the same like x. That therefore means if we differentiate, guys, we are going to have dx to be the same like cosine of u du. Good. That's what we have, guys, because if we differentiate sine u, we are going to have cosine of u. Since we are differentiating with respect to u, we have du. Good. So guys, that's what we have. So now we are now going to change the limits of integrations, because our aim is to live completely from the x world to the u world. So we are going to have our table of this form. We need the x, we have the x values ready, and we need the u values. Good. So friends, we need a u value when x is 0, and we need a u value when x is 1. Good. These are the values that we have. So friends, when x becomes 0, we are going to plug in the 0 here. We are going to have u to be the same like sine inverse of 0, and that we all know, guys, gives us our answer of 0. So we come back here and say that we are going to have here to be 0. That is, when x is 0, we put in the 0 here, we have sine inverse of 0, which gives us 0. Now friends, when x becomes 1, we plug in the same 1 here, we are going to have u to be sine inverse of 1, right? Good. And as you all know, guys, this is simply going to be 90 degrees, or pi over 2, or a half pi. So this is just going to be pi over 2, or half pi. Good. This is what we have, guys, now. So we are ready now to take the integral completely from the x world to the u world. Good. So friends, this our integral now is now therefore going to translate into, when x is 0, guys, we have u to be 0. When x is 1, we have u to be a half pi. So this is going to translate into the integral going from 0 to half pi, or pi by 2, of e raised to the power negative, our sine inverse of x, guys, is our u, right? Good. It's our u. That's why we have the u here. Then, guys, our dx is what? Cosine of u du. That's why we replace dx by cosine of u du. Good. So this is what we have now, friends. That's it. Then, friends, at this point now, how do we go from here, friends? What do you think? How do we go from here? Good. This is a very nice form for integration by parts, right? So friends, you discover that we were able to start with u substitution. Now we are using integration by parts. So there are some integrals that you need to use both methods before you can finish it. Example, guys, the one we are integrating just now. So friends, we are going to be using the di method, because that's the shortest method you can think about. Okay, for integration by part, that's the shortest. So we are going to have our d and we have our I. Then, guys, the signs we are going to have here alternate between positive, negative, and positive. So we have positive, negative, positive. We need just 3 rows, guys, just 3 rows. Why are we saying 3 rows, guys? Because we are going to choose one part to integrate and the other part to differentiate. In this case, guys, even if no matter the function you choose to integrate, you still have the same result. Okay, you still have the same. So we are going to, let's just say we are going to be differentiating e raised to the power negative u, and we are going to be integrating cosine of u. Good. That's what we have. Then friends, we are going to differentiate cosine of u and integrate cosine of u one more time and do it again, so that we can come back to the same cosine of u, which is exactly what we have, right? So differentiating e raised to the power negative u, guys, we are going to apply the reverse chain rule. We have negative e raised to the power negative u. One more time again, guys, we now have e raised to the power negative u. Great, that's what we have. Then friends, integrating cosine of u brings us to where? To sine u. Good. So integrating cosine of u, guys, we have sine u. Keep in mind that here we differentiated sine u and we had cos. So integrating cosine of u now brings us back to sine u. That's what we have. Then integrating sine u, guys, gives us negative cosine of u, as we have. Great. That's it now. Then friends, now the therefore implies this our integral now. The integral going from 0 to half pi of e raised to the power negative u cosine of u du now turns out to be, now friends, we are going to multiply the diagonals. We multiply this our diagonals, then multiply this our last row and still put it inside of the integral. So we are now going to have negative e raised to the power negative u multiplying sine of u. Then we are going to have this term as well, multiplying negative cosine of u. Good, that's what we have. So friends, keep in mind that we have e raised to the power negative u on both sides, right? So we can factor it out. By so doing, we are definitely going to have sine of u, this sine of u. Now keep in mind that there's a minus and there's a minus here, right? So it gives us positive, but there's still this minus, so that's why we have the minus cosine of u. Then we have e raised to the power negative u. That is where we factor it out. Then friends, we multiply this our row and still put it inside of the integral. So this is positive, this is minus, we have minus. We are going to have negative of the integral going from 0 to a half pi of e raised to the power negative u cosine of u du. Good, that's what we have, friends. So friends, what do you notice? You notice that on the left hand side we have integral from 0 to a half pi of e raised to the power negative u cos u du, and we have the same quantity here, right, but in negative. So we are going to bring it to the left hand side. By so doing, we are now going to have 2 times the integral going from 0 to a half pi of e raised to the power negative u cosine of u du, which is the same now as sine of u minus cosine of u e raised to the power negative u. So friends, keep in mind that we have to evaluate the integral of from 0 to that. Okay, not 2 times the result, not 2. So we have to isolate the 2 by simply dividing all through by 2, so that we are going to have the integral going from 0 to a half pi of e raised to the power negative u cosine of u du, which is therefore equal to half of this, okay, half of this our function here. So we now have to plug in the limits of integrations, guys. When our u is pi over 2, we plug everything here, guys. Keep in mind that sine pi over 2 is simply 1, then cos pi over 2 or 90 degrees is 0. Then we have it here. So when we plug in the upper limit, we are going to have 1/2 times this is going to be 0, then sine pi over 2 is simply 1, then we have e raised to the power negative pi over 2 minus, guys, the lower limit. When we plug in 0, sine 0 gives us what, guys? 0. Okay, cos 0 gives us what? 1. So we are going to have, then here becomes nothing, so we are going to have minus 1/2 into negative 1. That's what we have, but the negative makes it positive, right? Then we have 1/2, so we can factor that out. By so doing, guys, we are definitely going to have 1/2 into 1 plus e raised to the power negative a half pi. Great. So friends, that's the end of our answer. That's the answer. Thank you so much, guys, for watching the video, and see you in my next video, guys. Please subscribe to the channel and like the video. That goes a long way to motivate me, and put your comment down below, guys, what you think about this question. Thank you, and have a blessed day.